Okay. Yeah.
And you got click one by when you started behind that. Yeah.
Hey, you should have your book open to page 68. Okay, your attention in 5, 4, 3, 2, 1. Thank you. So we have G, A, T on the DNA. And if we are looking for the complementary RNA codon, that means the one that matches up with it. So, but we have to remember that it's RNA, so this is mRNA. And so what's going to match up with it then is G goes with C, A goes with, well, it would go with T if it were DNA, but it's not DNA, so it is U. And T goes with A, so it's going to be CUA. Now, this mRNA has this codon CUA. Has a complementary tRNA anticodon. So the complementary tRNA codon is going to be complementary to the mRNA because those are the two that match up, right? When it's going through the ribosome, you've got your codon and you've got your anticodon. And so C matches with G, U is complementary to A, and A is complementary to U. So the complementary tRNA code would be GAU. And one thing you might notice is that the DNA molecule, the triplet on the DNA, is GAT. The complementary tRNA, you have to go through mRNA first, but you basically end up back where you started with the tRNA, because you've been complementary and then you're complementary again, except for that the T changes into a U. Okay? This next one, we're going to work backwards. So if our tRNA is A, C, U, then the mRNA that is complementary, A goes with U, C goes with G, and why did I put a T there? That's weird. Let's just put a line there. And U goes with A. So this is going to be UGA. UGA. And then going backwards again, our mRNA is UGA. Who is the complementary DNA triplet? And you'll notice I'm not pairing up DNA with tRNA because they never pair up with one another. The mRNA copy is made off of the DNA, but the tRNA always matches up in the ribosome with the mRNA. So mRNA and tRNA always go together. mRNA can go with tRNA or it can go with DNA. U goes with A, G goes with C, and A goes with U. So we would have then our DNA would be A. Oh, what did I do wrong? That's DNA, so what should I not have? I should not have U. Instead, I should have T. So it should be ACT for DNA. And then we're going to start from mRNA. We have UAG. And who is the complementary DNA? This time I'm going to try to remember to use T, because it should be T and not U. This is going to be U goes with A goes with T, and G goes with C. So A, T, C. And then once again, we're going to have our mRNA. This time, UAG, we want to say, what does it go with for the tRNA? U goes with A goes with U, and G goes with C. And you'll notice once again that the DNA triplet and the tRNA anticodon are the same, except that the T and the U are different. Yeah? So if you have a tRNA codon that is UUG, the DNA is going to be the same, except that you're going to replace the U's with T's. T, T, G. If we wanted to go through the whole process, if our tRNA is UUG, our mRNA would have been AAC, and the DNA would be TTG. Okay? So hopefully that clears it up. It is one of the trickier things. So if you don't actually get that in grade 9, it's not the end of the earth. But yeah, that is one of the trickier things. Was there anything else from any of the work that you did yesterday that you had questions about? Nope. Okay. Today, we're going to take a look at chromosomes and alleles, and I don't know what happened to my page. It just jumped away from me. There we go. 5.5b on page 120. We're going to start by watching the video, and then we'll take notes. So don't worry about taking notes right away. Just pay attention to the video. Make sure we've got good volume on here. Yes, we do.
Hello, you are watching.
Okay. Remember, where are your eyes when a video is on? Point. Yes. Where are your ears when a video is on? Up there. Okay. Or up here, because it's coming out of there. All right. Very good.
Quick definitions stated clearly. What is an allele in genetics?
So that is pronounced allele. I did have one class one time who insisted that it was allele, which I did find kind of fun. So if you wish to refer to it as an allele, you feel free. It actually might help you spell it. I don't know. Anyway, the official pronunciation is allele.
As we've
Allele.
learned in earlier videos, a gene
Oh, and we're going to put on our subtitles as well. There we go.
is a stretch of DNA, usually a long stretch of DNA, that codes for something.
What does it
exactly
code for?
do genes code for? Technically, they either code for specific proteins or they act as templates for functional chains of RNA, but
Okay, my button is working. Okay.
because proteins and chains of RNA go on to produce traits, things like eye color and bone length, we can say that an organism's genes, in a roundabout way, code for an organism's traits.
So genes code for proteins, but in a roundabout way, they code for your traits. What's another word for traits? Characteristics.
An allele is an alternative version of a specific gene.
Every single gene is an allele. Okay? It's a bit like isotopes. Every atom is a particular isotope of that atom. Carbon-12 is one isotope. No, snooze. No, do not know. No. Yes, I understand there's 14 minutes. Give me 14 minutes. Burnaby School District. It's okay. We'll get through this.
If that sounds confusing, that's okay. It should become clear once we see a simplified example. Let's say there is a gene in a species of frog that codes for the frog's eye color. We will call it the eye color gene. No need to get too creative here. This frog
I'm actually going to see if I can close this and open it again, and see if it will, go in front, but it doesn't look like it's going to. Nope, it's not going to. Do you know what?
Hello.
You guys are just going to chill for a minute while I restart the computer, because it's going to sit here with this thing on top and it's going to restart right in the middle of our lesson, which is crazy. So I'm just I can't even, oh my gosh. Yeah, so you guys are just going to chill for a minute, okay? You get to